Hi guys, today we're going to learn about the exponential functions and how to integrate exponential functions. So, the integral of an exponential function is the integral of e to the u du is going to be equal to e to the u plus c. So, in this case, this example that you have here, you want to integrate e to the 3x plus 1 dx. So, what's going to be your integral? So the first thing that you need to do as usual is to do u substitution. In this case, I would recommend you to do the u as the exponent of the e. In this case, you have 3x plus 1. Therefore, the derivative of that is going to be 3 dx. Therefore, you don't have the 3. So what we're going to do here is you are going to move the 3 to the other side, having a 1 over 3 here. So you have that it's going to be the integral of e to the u du. So once you have the situation, it's very similar to the formula. Therefore, what you have is 1 over 3 e to the u plus c. So you are done integrating. But we need to go back to our original u. In this situation, your u, it was equal to 3x plus 1 plus c, and that's what you have for this problem. Isn't that nice? So similarly, what you have for this one, even though it looks like a lot, you have that it's the integral of 5x e to the negative x squared dx. You're going to tell me, how do I start? Well, look at the exponent of the e. The e is alone, so look at the exponent of the e. Do you have that derivative? The derivative of that is negative 2x dx. And you're going to tell me, I don't have the negative 2. But you do have the x and the dx. So the negative 2, and remember that when you have constants missing, you can manipulate the constants. What you cannot manipulate is the variable. So what you have, you can move the 5 outside the integral using the integral properties. Okay? So you have the negative 2 here, integral of e to the u du. Okay, so now it becomes pretty simple, because you know that the integral of e to the u du is equal to e to the u plus c. So now you go back to your original u, which in this case, what was it? It was negative x squared. So that's what we have. Isn't that nice? Similarly, for this problem, what you're going to do again, even though it looks a little bit intimidating again, you're going to substitute the exponent as the u. So you have u is equal to 1 over x. Therefore, du is equal to negative x divided by x squared, because that's the derivative of this guy. The only thing that you don't have, because you do have the 1 over x squared dx, but you don't have the negative. So don't worry about that, but the negative here, then the integral e to the u, because that's what you have, and then du. Isn't that nice? So now you can integrate this beautifully, because you have that it's negative e to the u plus c. So go back to your original u, which in this case it was 1 over x plus c, and that's it for this problem. Okay? So again, here you are going to have something that looks a little bit intimidating, but don't let that again to intimidate you. Let your exponent to be the u. So in this case, you have cosine of x. What's the derivative of cosine of x? It's going to be, what's going to be the derivative of cosine of x is going to be negative sine of x dx. Therefore, the only thing that we're missing here is the negative, but that's not a problem, because you can put it at the very front. So you have the integral of, and the sine dx, you have the sine here and the dx. So you have the du and the e to the u. Okay, you have it over here. So again, you have that it's negative e to the u plus c. So this is going to be equal to negative e to the power of cosine of x plus c, and that's pretty much it for this problem. Isn't that nice? Let's go back to another problem that it looks a little bit different. So this one that we have over here, if you just look at the exponent, then you would have that u is equal to x, which it would not help you at all. Okay, so you need to think a little bit different. What would be your u in this situation? Okay, so you can see that you have a more complicated situation here in the denominator. So let your denominator be your u. So the derivative of that expression in the denominator, you know that this is going to be 0, and this is going to be e to the x dx. So I do see this guy at the top. Do you see it? So that's perfect. Why? Because we can do u substitution. Okay, so far what I have is okay, instead of e to the x dx, you have just du, and you have 1 over u. Now the business is we do have limits of integration, so you need to change the limits of integration. The lower limit, what's going to be the business of the lower limit? You're going to plug 0 here, so you have 1 plus e to the 0, which that's 2. Okay, so that's going to be your lower limit. Now, what's going to be the upper limit? The upper limit, you are going to plug what into the e? 1. Okay, so you have 1 plus e to the 1, which is 1 plus e. So you plug 1 plus e here. Okay, so that's going to be your upper limit. Okay, then you ask yourself, can I integrate this? And yes, that's one of your new friends, the natural log. Okay, so natural log of absolute value of u evaluated from 2 to 1 plus e. Okay, so that's going to be your integral. Now, what are you going to do here? From here, you are going to substitute your u for the 1 plus e, okay, minus natural log of 2. Now, you're going to tell me why you took out the absolute value. Because I know that this is a positive number, and I know that this is a positive number. So that's why I pretty much know that this is going to be positive either way. That's why I was able to remove the absolute value. Now, in the AP test, it wouldn't be like this. It would be condensed. So you would have 1 plus e divided by 2. Okay? So either this or this representation, they are correct. However, if it's a multiple choice, they are going to simplify it as much as possible. Okay, so to test if you do know the properties of logs. Okay, so that's why. Okay, so the next problem that we have over here, we have the integral from -1 to 0 e to the x cosine of e to the x dx, and you're going to tell me again, this looks like a monstrosity. So what are we going to do? Well, think clearly. So I can see that we have an ex, then we have a cosine, and inside the cosine you have something else. So I would do the most inside thing that you have as a u. So the most inside thing that you have is the e to the x, specifically this one. Okay, so that's your u. The derivative of e to the x, you know that it's itself dx, which is great, again, because you do see this guy and this guy outside. So the only thing that we need to worry now is to change your limits of integration. The lower limit, which is -1, you just plug it here, so we have that it's e to the -1, which you can represent as 1 over e with exponent properties. And then the upper limit, you know that you are going to plug the 0 here, so you have e to the 0, which is going to be 1. Okay, so pretty nice. You have your limits of integration, so you have that it's going to be the integral from what? 1 over e to 1 of what? You have that it's going to be cosine of u du. Okay, so are you cool with that? So now that you have the situation, what happens? You're like, oh, the integral of cosine, that's not bad, that's just sine, okay, of u, and that's what you have. Now you just need to evaluate from 1 over e to 1. Therefore, you just replace your u for the 1 over here, and then your u for the 1 over e over here, and I don't know why I put those parentheses, but this would be your answer. Why? Because this is not part of the unit circle, so I would leave it like that. Okay? Over here, what we have is we need to solve the differential equation dy dx e to the x minus e to the negative x squared. So what in the world they are asking you to do? Well, they are giving you a derivative. So what you want here is to get the original function y. Okay? So to find your original function of when you have a derivative, you need to integrate that situation. So let's integrate this. Okay? So you ask yourself, okay, so I need to integrate this equation. Can I use u substitution? And the answer is, as it is, I don't think so. Why? Because what you have over there, it's not very user-friendly, because if you have u as e to the x minus e to the negative x, the derivative of that is e to the x plus e to the negative x, and I don't see it outside. So the best shot here is to expand this via algebra 2. So you know that this expression that you have over here is equal to this, multiplying these two algebraic expressions. Do you agree with that? So I know that when you multiply this times this, you have that it's e to the 2x. When you multiply this times this is negative e to the x minus x. This times this is negative e to the negative x plus x. And when you multiply this times this is going to be positive e to the negative 2x. So this is going to be a negative 1 and this is going to be a negative 1. So this is going to be a negative 2. Okay, these are like terms. This is not a like term with this one. So you can break down your integral as follows. The integral is going to look like this. The integral of e to the 2x minus 2 plus e to the negative 2x dx. Do you agree with that? And that's what we have here with algebra 2. Okay, so what I will do here, so you don't feel so overwhelmed, you can always break this into 3 mini integrals. Okay, so you have this and then you might have this, so it looks a little bit more user friendly. Okay, so here you can do a u substitution or not. Okay, but you know that it's going to be 1/2 e to the 2x minus the integral of negative 2 dx is negative 2x, and this integral is going to be negative 1/2 of e to the negative 2x plus c. You're going to tell me why it's negative, because your u here is negative 2x, so the derivative of that is going to be negative 2 dx, and that's why we have the negative 1/2 here. Therefore, that's it. Thus, my expression y is equal to 1/2 e to the 2x minus 2x minus 1/2 e to the negative 2x plus c. That's going to be your what we call the general solution. Okay? For this problem, you want to find the particular solution of the differential equation that satisfies the initial condition f of double prime being equal to sine of x plus e to the x, f of 0 equals to 1 over 4, and f prime of 0 equals 1 over 2. Okay, so here, what they are giving you is the second derivative. Okay, what we want, because you want the differential equation, you want the original f. Therefore, we need to start with the derivative, the first derivative. How can we find the first derivative? You can find the first derivative by taking the integral of the second derivative, okay? And then what you're going to do is you're going to evaluate whatever you have here, okay, into your result, okay? You're going to see it in a second, but first, let's take that integral. That integral that you have is nothing more. What's the integral of sine of x? You know that it's negative cosine x. Then the integral of e to the 2x, you know from the previous problem that it's 1 over 2 e to the 2x, excuse me. Okay? Plus, I'm going to call it c1. Okay? So, over here, what you're going to do is you're going to replace the x for the value that it was given to you for the first derivative. In this case, is 0. So plug the 0 in the cosine, okay? And then you have that it's going to be 1/2 e to the 2 times 0 plus c1, and that must be equal to 1/2. This is 1/2 and 1/2, they cancel, this is negative 1. So you have that c1 is going to be equal to 1. Therefore, I know that my first derivative is going to be equal to negative cosine plus 1/2 e to the 2x plus 1. So I have here, okay, almost my expression, but now I have the c, okay? Now I can start thinking about original f. What is original f? Original f is going to be the integral of f prime, which in this case is negative cosine x plus 1/2 e to the 2x plus 1 close it dx. Okay? Now, what you're going to do here is integrate piece by piece. The integral of negative cosine is going to be negative sine of x. The integral of 1/2 e to the 2x is going to be, careful with this one, is going to be 1 over 4 e to the 2x, because you are missing that 2 that it's next to it, so again you need to complete it. Okay? And last but not least, you know that the integral of 1 is just x, and then you have the plus c, and in this case I'm going to put c2. Okay? So I'm going to put it like this so you can see it. Okay? So what do you have here? I need to find that C2. The good thing is that they gave you an initial value, which it was f of 0. So you just replace the 0, okay, as your x. So you have sine of 0, which you know that it's 0, plus 1/4 e to the 2 times 0, okay, plus 0, okay, plus C2, that should be equal to, according to this, 1/4. This is going to be also 1/4, 1/4. This is a 0, so you know that C2 is going to be 0. Therefore, okay, what's your conclusion here? My original function, f of x, is going to be equal to negative sine of x plus 1/4 e to the 2x plus x plus nothing, because it's a 0. And that's pretty much it for this problem. Okay, I hope that you find this video helpful. Bye!